evaluate. We've been told to evaluate. What are we evaluating? We are evaluating an integral. So remember, we talked about two types of integrals in our lessons. Those were indefinite and the definite. So we said when we have been given limits, we are going to integrate in a certain pattern. And then when we have not been given limits, we are also going to integrate in a different pattern. So now let's go over this question. So part A, we have been given the integral of from -1 to 2. Sorry for that. Then this is 2 plus x minus x squared, everything x. So this, we're saying we should integrate this function of 2x plus a, 2 plus x minus x squared with respect to x when we have been given the limit from -1 up to 2. So here we're just going to say, okay, this is equal to, so remember, the integral of this coefficient. So this is just going to be 2x over 1 plus x squared over 2 minus x 2 plus 1 over 2 plus 1. This is going to be everything. We introduce our limit. Now, we are not going to include the constant c because we have been given the limits there. So we are going to say this is from -1 up to 2. So from there now, the next thing we're going to make sure that we leave this our expression into the simplest form. So this is simply 2x plus x squared over 2, everything minus x. 2 plus 1, we get a 3 there. Then 2 plus 1 again, we get 3. In short, what we have on top there is what is going to reflect down there when we integrate. So we're going to say everything in the brackets of from that's -1 up to +2. All right, so from there, we should be able to say that. So we're going to get this 2 and replace into this our function, and then everything minus when we replace this -1 into the function. So this is simply 2 only 2 plus 2 squared over 2 minus 2 to the power 3, everything over that. Then in brackets, we say minus. Now we are going to substitute in the value of -1 into the whole lot of that function. So this is simply, sorry for that. All right. So this is going to be minus, so we have 2 on -1 plus -1 to the power 2, everything over 2, minus -1 to the power 3, everything over 3. Then we have that. So now we can get our calculator because this is a paper 2 question. So we can get a calculator and punch in those numbers. So we have a 2 multiplying 2, that will give us a 4. Then this 4, we are saying we have got a 2. Okay, so we have a 6, which is minus 8, everything over 3. Right. So on this side, for the value of 2, we simply have a 10 over 3, everything minus. So we are going to have negative 2. Okay, negative 2 plus half everything minus 1 over 3. No, actually, it's not a minus. It is a positive. All right. So this other side, we get a negative 7 over 6. So here, our final answer is simply going to be 10 that plus 7 over that, which is simply 9 over 2. We can write this final answer as 4.5 square units. All right. So that is all we needed to do for the first part. That is all we needed to do for the first part. Now let's quickly. So remember, if you have not understood, the main reason might be that you've forgotten the concept, or you have not watched the videos for the lessons that we did. So make sure you watch the video. After you watch the video, you are going to see that these questions are actually very simple. You need to get all the marks that they give you on this particular problem. Sorry. For the second one. Okay. We are going to say, right. We are going to say B. So for B, find the equation of the normal to the y equal to x plus 4 over x at the point where x is equal to 4. So this problem, remember, you have got a function f of x, which a x plus b. So if you have this function, we said when you integrate this function, you remain with that. Let's have this quadratic expression. You're going to have 2ax plus b. So now this is your gradient. Remember what we said. If this is your gradient, now for you to get the gradient function, if this is the gradient function, if for you to get the actual gradient, you are going to get the values that you've been given for that particular point. So you're going to get the x value. Suppose it is k. You're going to get that k value and replace there. Whatever you're going to get is the gradient. Now, if you have not been given that, what do you do? So there are times like in this problem where you are going to outsource some other data. So now let's quickly see what we mean. Let's quickly see what I mean. This question is very simple also. So we're going to say B. So for B, find the equation of the normal. So y equal to x plus 4 over x, where x is equal to 4. So here, the first thing that we needed to do is we needed to to get the y value. How do we get the y value? So I'm simply going to say y is equal to get this x and replace whatever there is x in this equation rather, plus 4 over 4. So this will give you 4 over 4, it's 1. So everything will give you a 5, like that. And then after you're done, you are going to say y is 5 and x is 4. So your coordinate where this equation is cutting is 4, 5. Okay. So after that, you're going to get the gradient function. So your gradient function is going to be x plus 4 over x. Now you're going to differentiate this one. You're going to differentiate this function that you've been given. So for you to differentiate that, you say do y dx, others might say y prime. Is that okay? So you're going to say, oh, sorry, before we can differentiate that, okay, let's switch to this other side. Let's see what is happening here. We have y equal to x plus 4 over x. Now, remember that we said whenever you're differentiating, this x should be a base, not a denominator the way it is here. It should be a base always. So we're going to say y is equal to x plus 4, this multiplying x to the power negative 1. Now, one might ask, where is the negative 1 coming from? So remember that one of the properties, okay. All right. So one of the properties of indices, those of you that have watched the video on the indices, we said if we have 1 over a, this is simply a to the power negative 1. If we have 5 over y, this is simply, you are going to multiply this, say 5, multiply this y, but it should be to the power negative 1. So anything, say you have b to the power negative 1. If you have this expression, this is simply 1 over b. So this is the concept that we are using. This is the concept that we are using. So we are going to say all right. So we are going to say this one is the same as x plus 4 x to the power negative 1. Now to differentiate this, we're going to say this is 1 minus this will multiply with that to give us a negative 4 x to the power negative 2. Okay, so your dy dx is equal to 1 minus 4 over x squared. So now remember that x is equal to 4. So we're going to say, so now this dy dx, the first derivative you get, it is, since we are in calculus, we're going to say this is equation, this is gradient of the tangent. That is gradient of the tangent. So we're going to say mt minus 4 over 4 squared. Now this is 1 minus 4 over 16, which is simply 1 minus 1 over 4. Okay. So what is 1 minus 1 over 4? So this is simply, so we are getting our first gradient. We call it mt, gradient of the tangent. This is simply 3 over 4. Now remember, we said if you have gradient of the tangent, mt, for you to get gradient of the normal, you are going to say mn equal to -1. So gradient of the tangent multiplying the gradient of the normal should give you -1. Tangential rule there. Those of us that did calculus lessons together with me. So we're going to replace a 3/4 and multiply with that, equal to -1. So for us to get rid of this so that we leave mn, gradient of the normal, alone, we're going to say 4/3. Even this side, 4/3. So we're going to say mn, because this and that will go, this and that will go. So we're going to say -1 times 4 to give us -4 over the we're supposed to say over 1. 1 multiplying a 3, this will give us a 3. So this means that our gradient of the normal is simply -4/3. Now, since we have our gradient here, and we also have the coordinates there, so we can get these are coordinates and say 4,5. So we have the information that we need for us to get the equation. Okay. So let's quickly get okay. So to get the equation now, we're going to say y minus y1 equal to m, this is gradient of the normal, equal to open bracket, I mean x1. So now you've got all the information that you need. You're going to say, since you have gradient of the normal as -4/3, then you have got your coordinates as 4,5. So this is your x1, this is your y1. You're going to say y minus your y1 is 5 equal to mn is -4/3. X minus our x1 is 4. So y minus 5 is equal to, so you can now multiply. So this is going to be -4/3 x. The negative and negative will give you a positive. 4 times 4 will give you 16/3. So from there, I'm going to say y is equal to -4/3x, then plus 16/3. When this -5 comes this side, it will be +5. Then this will be equal to -4/3x plus. So we can add 16/3 plus 5. So we simply get 31/3. Okay. So our function is -4/3x plus 31/3. That was the equation of the normal. Equation of the normal. These questions are very nice. These questions are very nice. So the next question is asking us to evaluate also. It's telling us to evaluate. We should evaluate. Okay. Evaluate the integral. Evaluate the definite integral there. But before I can solve this one, I think just pause the video and see what you're going to do. And then after that, you compare with whatever I'm going to get. Compare with whatever I'm going to get. Okay. Okay, so we are on question 2a. So for part A, we have the integral of that limit from 0 to -2 to 1, then x squared minus 2x plus 3 with respect to x. So this is simply going to be x a power, you say plus 2. So this is plus 1 over 2 plus 1 minus 2 x. You had a 1 here. Now you are adding another one. So you have that plus 3. This is x to the power 0 plus 1 over 0 plus 1. Everything like that. So we are going to get x to the power 3 over 3 minus 2x to the power 2 over 2 plus 3. This is just going to be x to the power 1, which is simply x. Then 1, which is just that. So we can introduce our limits. This is like that. So this is going to be, when you replace this one, so you always start with the one that is on top. So you replace this one in the expression. So we're going to have 1 to the power 3 over 3 minus 2, 1 squared over 2 plus 3. You place a 1 there. Everything minus it. So you have a 0. So 0 to the power 3. Then minus 2. 0 to the power 2 plus 3 multiplying by 0. So this is going to be, this is just 1 over 3 minus this is 1, this is 3. Okay. Minus it. Now this side, you notice that this side will give you a 0 because 0 to the power 3 is 0. 0 divided by 3 is 0. 0 to the power 2 is 0. Multiplying by 2 is 0. Divided by 2 is 0. 3 multiplying 0 is 0. So this side will just get a 0. Then you say equal to. So you're now going to add this side. So you get that plus plus 3. So the final answer here is 7 over 3, which can be evaluated as 2 1/3 square units. Okay. But it's not so necessary that you include these units. Just leave the answer like that. Just leave the answer like that. Okay.